That's pretty bad.
Thank you. I wrote that myself. Thank you. I don't know why they say aye, aye, Captain. I mean, clearly the guy, you can't be saying aye, aye. You should be aye, Captain, right? So let's take a look at Desmos here, right? I've got my 2 points. I wanna see that my secant line crosses both, right? So what did I get? Y equals negative. Help me. What was my slope?
No, -3 on 75, I think.
Yes, thank you. -3 divided by 7 pi, right? Times x. And there's my secant line. You see it crosses. I don't care so much about that it's crossing the curve later. I only care about that it's crossing those 2 points, right? Right, you with me? Secant in that it crosses the curve twice. Yes, it might cross other times, but I only care about that it goes through those 2 points, right? Now, I would like to create a dynamic secant line, and I'd like you to be able to do this. It's something I always ask my calculus students to do. So I want to create a secant line through 2 points, the first one being x, the second one being x plus h, right? So is it okay that I move on? Is everyone okay here? Everybody understanding? Ryan, Cindy, Oscar, Ryan, thank you. Ben, Wilder, Elise, Yvonne, thank you. So I want to create a dynamic secant line, and I'd like you to be able to do this. So I'm going to use my sine curve, and I'm going to create one point at x, so I got x sine of x on the curve, and some point later h, right? So I have x plus h sine of x plus h. And I'm going to connect those with a secant line. Now I'm really interested in my original point being at x is 0, right? And that's what we already saw. If x1, y1 is at 0, comma, sine of 0, then the secant slope is sine of h over h, right? That's what we've already demonstrated that today. Okay, I did my difference quotient and simplified it as much as I could, knowing the original point was 0, 0. And you'll see I'll move that point to 0, 0. Okay, I'll move this point right now that's set at x sine x. I'll move it to 0, 0. Okay, just so you can see where I'm really interested in. So because I've got my secant line and all of that already figured out, I'm gonna get rid of this stuff. I don't want to show this. I want it to be a little cleaner on my page. So the first point I'm going to put out is a comma sine of a. The program itself will get confused if I use x again. So x is the general. So if I want to pick a specific point, I'm going to pick a. So a comma sine of a. And I can create that slider a. So you can see I could either move this point on the curve, or I could move the point with my slider over on the side. So I could drag the point on the actual function. I've got a touch screen. So you would, if you didn't have a touch screen, you'd have to, I think you can just click and it would change your value of A. Or you can animate it, right? You could just move, you could hit the play button and it will move that point on the curve, right? Is that making sense? So there's my first point. The other point I want is A plus H, comma, sine of A plus H, right? So I want A plus H, or X plus H, right? A plus H, comma, sine of A plus H. And that's my second point, right? And I'm adding the slider H. And so there's my second point. Now that one I'm gonna move. The first point I'm gonna stay fixed. So A comma sine of A, I'm gonna keep it fixed. In fact, you know where I want it. I wanted it at A is 0, right? I already told you that I want it there, right? Now I know this equation of the secant line. Anybody help me? What's the equation of the secant line? So I have the points A comma sine of A and A plus H sine of A plus H. So I need a slope. What is that?
Over 8?
Yeah, sine of A plus H minus what?
Sine A.
Sine A. All over what?
A plus H minus A.
So just H.
No, H.
Just H, right? F of X plus H minus F of X all divided by H, right? Now, of course, I know if A is 0, sine of A is 0, right? But I'm going to put that into my curve anyway, right? So I need y minus y1 equals m sub sec, the slope of the secant line, times x minus x sub 1. And remember, I'm using A sine of A as my x1, y1. So I'm using y minus sine of A equals that m sub sec, secant line of x minus A. And that's what I'm putting into my, right, that's what I'm putting into the Desmos. Is this too much? Are we okay here? Anybody freaking out? Yes, Cindy, question.
No, it's just I'm freaking out.
You're freaking out? I don't blame you. I don't blame you. This stuff is pretty dense. And you don't all have to get everything the second I say it. The thing is, you have to go back and rewrite it. You have to go back and play on Desmos. You have to go back and read the book. You have to do some research. You have to put in the time. This is your job. If you're working at a restaurant and you didn't know the menu by heart, you better go home and memorize the menu. If you're going to really work there, okay? So I'm asking you, memorize. And then you'll start to talk about, well, what's everything taste like? Then you get into the soul of it, right? So that when someone orders something, you could say, oh, this has got great flavors, like whatever. You know what I mean? You don't just have to memorize things. You have to really get into it. Cindy, question?
Have to go back and practice.
Yes. Yes, we all must. We all must. So I'm putting in now my secant line. Y minus sine of A equals my secant slope, which was sine of A plus H minus sine of A, all divided by H times X minus A, just like I wrote on the other page. And now you can see that I'm actually touching, I'm crossing There's 2 points, and notice that they're both draggable. So there's my x plus h, there's my x. So anytime I move right one, I'm changing my secant line. Now I'm really interested in x, that original a value being 0. 0 comma sine of 0 or 0 comma 0, right? And what I'm really interested in is making h go to 0. What happens when h goes to 0? Can you see it? Where's the slope going when h goes to 0?
Negative.
It's going towards like 1. It's like
You
in
can
the
you can
zero
you can
to-
actually calculate that slope right now looking at the grid. Look at my grid. What's the slope of that line?
Oh, 0, 2.
No.
sine of A.
One number. It's a single number. What's the slope?
2.
Not 2.
Zero.
Nope. 0 would be right horizontal, right?
So 1 and 1.
1. The slope is 1. The height is 2. The base is 2, right? So 2 over 2. Delta y over delta x is 1. What's crazy about this, and this is a calculus problem, is that I told you when I'm at 0, 0, right? When I'm at 0 comma h, I'm getting a sine of h over h, right? And now I'm letting h go to 0, right? You with me? If I let h go to 0, I get sine of 0 over 0. And what is sine of 0 over 0? 1. What the hell? Sine of 0 over 0? 0 over 0 is 1? Sometimes. This is the crazy thing. This is a big part of Calc 1, is that sometimes when we have a 0 over 0, we get 1. Sometimes we get 0. Sometimes we get infinite. It's called an indeterminate form. But pretty clearly, we can see that this slope at this point, as h goes to 0, right? We can see that this, even if I let h get even closer to 0, right? 0.03, my h is 0.03 right now. Look at that slope. 1, right? Can I get it a little smaller? Can I let it go to actual 0? If I let it go to actual 0, it disappears, right? Because I can't have a line with only 1 point, right? This is the beauty of calculus, is that we can have a line with only 1 point in calculus, right? How are we doing? Nice. So there's little subtleties in homework 6. Homework 6 is all one chapter. So I've been doing homeworks as 6-1, 6-2, 6-3. I did all of 6 as one chapter. I think there's about 13 problems in it, and then there's a little subtleties on this secant slope with trigs. Make sure you do those. They're also in the test review, and I put a minimum score of 3 out of 13 on the test review for chapter 5 and 6. Okay, so I'm expecting you to work on the review. Please do not wait until Thursday, November 11th. Our test is Friday, November 12th. The following Monday, you will get an updated grade from me with your homework average and a prediction grade for your final exam. That prediction grade will say, like, if you get an 82 on your final, you'll keep your A. If you get a 72 on your final, you'll get a B. If you get a 62 on your final, you'll get a C, something like that. And then you can decide, because Tuesday, the 16th, is the last day to drop the course, right? It's kind of sad that I have, 3, 6, 9. I have only 13 students here today. I'm supposed to have 20 students here. So it's kind of sad, but I don't know. I'll go back and make pizza or I'll deliver pizza again for my new job. Because obviously I failed as a teacher. I just laugh. I'm just laughing at it. Again, what else can I do? All right, here comes the difficult piece. We won't finish it today. We will finish it Wednesday. Okay, this is the last bit and the last question on your test 3. Okay, and it is about taking a sine curve and transferring it or translating it, right? Transformers, that type of thing. So we're going to be looking at this particular curve here, right? This curve right here. So this is it's section 6.6, I believe. So 6.6 graphs of trigs with a phase shift. So we're looking at this particular curve, y equals plus or minus a times the sine of b times the quantity of x minus c, all plus d. And I've got them all capitalized. It doesn't matter, but I put them alphabetical because I want you working on each of them in alphabetical order. So this is a reflection. A is called my amplitude. Amplitude, yes. It's easier to think of that as a radius. B is called the frequency. I like to think of that as the speed. C is called the phase shift. No, sorry. Which of course we know because it's inside and affecting the axis. This is our horizontal shift. I also like to call it the starting point. And then D is called the midline, or our vertical shift. I think I warned you that you needed some aspirin before this lesson because it's pretty dense. It's pretty difficult. I already have a headache because I taught it once already today. So I want to be thinking about this. And as I do any of these 5 pieces, reflection, amplitude, frequency, phase shift, midline, I want to be drawing the mother, the daughter, the granddaughter, the great-granddaughter, etc., etc. It's going to keep going down. It's many generations here. When I do the frequency, I will also do a period. So the period is going to be 2 pi over b. I'm going to do the quarter steps there. Which of course is the period over 4. So better yet, 2 pi over b divided by 4. And of course 1 step, 2 steps, 3 steps, 4 steps. And then when I do the phase shift, I have to get that starting point, right? And so I'm going to kind of marry these 2 pieces together. The starting point, and from there the quarter steps. Okay. Now, if I can remind you, I told you this was horrible, right? Yes, horrible. If you can't tell already, it's horrible. So I've got a nice little diagram that I made, and I would say it would be kind of cool if you could recreate it on Desmos. And something that's pretty cool that happens on Desmos is that if you log in and create an account, you can save things. So you can create something on Desmos and save it, right? But in this particular case, I've got my original mother function sine of x set here. And you can see my grid. My grid is amplitude up, amplitude down. So radius. So diameter is the height of my rectangle. The width is my period, 2 pi over b. I'm starting at C, right? If C is positive, I'm moving left. If C is negative, I'm moving right. And then my midline is at D. So for example, if I move my midline, if I move my midline down, the whole curve moves down. You can see the daughter function moving down. You can still see the sine curve in there, but I move D down, so everything moves down. If I move D up, everything moves up. If I move C to the left, my curve moves right. Remember, because x's behave inversely, that thought. So as I move that point C to the left, the value, the curve moves right. And if I move to the right, the curve moves left. Right? The whole box moves left. And the whole idea here is that I'm going to just create this rectangle with my quarter steps in it, and then I can easily draw the sine curve. Right? If I can just figure out where the box is, I can figure out really easy where the sine curve is moved.
So, Professor.
Yes, Jamal.
Could you say that when C is negative, the box is going to be positive, and when C is positive, it's going to be negative?
Yeah, so C is the starting point, right? And you can see C as my horizontal movement, right? Because it's inside. So if C is negative, my box is going to move right. Because x's behave inversely.
Got it.
Yeah. And then, so of course, A is my amplitude. It's just the radius of my circle. And then B is the frequency. This one's difficult, right? As I increase B, my X box scrunches because X's behave inversely. So if I'm multiplying by 2, it actually means give me half of the period. If I divide by 2, it means give me double the period. So that's pretty strange. But we've talked about it already. So our process is pretty complicated. I'm going to run out of time. I only have like 9 minutes left, so I'm going to run out of time. So believe me, you're not going to be able to finish homework 6 yet. Okay, homework chapter 6. So don't be okay with that. Do something else. Clean your damn room or something. You know what I mean? Do something else. You don't have to worry about this. After Wednesday, you can finish the chapter 6 homework. Okay. So, but the idea is that I'm taking account of these 5 processes as I go, and I'm drawing the mother, the daughter, the granddaughter, etc. as I go. So I want to do one example. I don't think I'll get it done, but I'll finish it next time. Okay. So y equals 3 times the sine of 2 times x minus pi over 3, all plus 1. So I have everything except for a minus in front, right? I've got a positive in front, right? So I'm going to draw the mother, draw the reflection, draw the amplify, draw the frequency, draw the phase shift, draw the midline. I'm doing everything in order, right? And there's a weird little connection I have to make. Once I get my period and the quarter steps and the starting point, I can use my process from chapter 12, sequences and series, to write out the quarter steps. Okay? So very, very complicated, very difficult. One question on your chapter 3 test. Okay? So I already know the mother, y equals sine of x, right? And I know I get a max of 1, a min of -1, and quarter steps of pi over 2. So I'm really looking at this box, right, with my quarter steps. And I know that my sine curve is coming from 0, 1, 0, negative 1, 0. So there's y equals sine of x. Everybody with me? Should be that quick. Anybody with me? Please, thank you. You can't just watch me do this stuff. You have to do it yourself. You have to sit there with a blank piece of paper and do this stuff over. Okay? You can't just watch me parallel park and then be good at parallel parking. When I start parallel parking, I always ask, am I a city boy or am I a country boy? If you're a city boy, you can parallel park only in reverse, one move, no back and forth crap. If you're a country boy, you hit the curb or you hit the other car. So you want to be city, not a word that sounds, not a word that rhymes. You have to practice this stuff. Next is my amplitude, right? So the amplitude is 3, right? That value of A. By the way, just real quick, y equals negative sine of x is the same idea, right? But it's going to flip all the, right? There's negative, y equals negative sine of x. So if I have that reflection, it's a reflection about the x-axis, right? And of course, each of these things you're putting in your calculator to verify, right? Which I'll do at the end. So my amplitude is 3. So that's saying now I have my original sine curve with my quarter steps at a height of 1, but my new curve is going to go from -3 to 3. So I can see my original curve here and my amplitude. So now I'm looking at this box now. Remember, I'm always going to be creating a brand new box every time I do something. I got to start at 0, go up to 1, which is go up to the radius, back to 0, down to the radius, back to 0. So there's my new, and I'm pretty sure you did that one in 098. Sound familiar? Look familiar? Changing the amplitude.
Yeah, we did all of it.
And this is amplitude modulation, radio waves, sound waves, amplitude modulation, frequency modulation. Amplitude modulation as I make my waves taller, and I tune into that on the radio. Frequency modulation is I make the wave faster. Okay, and that's what I'm tuning in onto the radio. So step 1, draw the mother. Draw the reflection if I have one. Find the amplitude, draw the graph with the amplitude. How are we doing here? I got 3 minutes left, 4 minutes left. We okay? Headache? How's a headache? Should be pounding right now. Jamal, headache?
Headache, sir.
Yes, should be. If you're paying attention, you should have a fierce headache right now. Next thing is my frequency. And that's that B value. And B, I got B is, what was it, 2? Yeah. Yes, you see it? Right, there's my amplitude. Here's my frequency. And it's important that it's factored out. Okay. So my frequency is 2. And so then that means I know the period is 2 pi over B. And in this case, that's 2 pi over 2, which is pi. So I'm doing everything, the whole curve, from 0 to pi, not 0 to 2 pi anymore, right? So I want to be thinking about, right? So up to 3, down to -3, and I usually will have quarter steps up to 2 pi, but now I'm going to have quarter steps up to pi. So my original function, my original box, right, in green, 0 to 3 to 0 to negative 3 to 0. Here's my sine curve. This is y equals 3 sine of x. Now I'm gonna change from y equals 3 sine x to y equals 3 sine of 2x. So I'm including in my frequency now. And so I figured out a period of pi, and I need quarter steps. So I need quarter steps now inside of 0 to pi, right? And so I'm going to get now, you can see that it's done the sine curve in half the amount of time it took me to draw the original sine curve. And this is what I'm calling speed. It's twice as fast. So if I went all the way to 2 pi, right, I would have to, again, get myself some quarter steps. But you can see I've repeated the sine curve twice compared to the sine curve once. That's what that frequency means, right? And it's 1 point moving around a circle. That's my sine of x. And another point moving around twice as fast. That's my sine 2x. And with a radius of 3, it's just a bigger circle. How are we doing here? How are we doing? Headache getting worse?
Yes.
It should. You're doing everything right. If your headache is growing and growing and getting worse and worse, everything's exactly as it should be. Quarter steps at this point, I can figure out how big my quarter steps are because I know the period. So I take the period and divide it by 4. That's a quarter step, right? So each step would be a pi over 4. Think about that. What did my quarter steps used to be? Pi over 2s. But this thing is happening twice as fast, right? So a quarter step is going to be half of the original quarter step. Half of a pi over 2 is a pi over 4. And that's what I got, a pi over 4. So looking at this red curve, I know I have a pi over 4. I have a 2 pi over 4, a 3 pi over 4, all the way to a 4 pi over 4, which of course is pi, right? So I figured out my quarter steps. And it's obvious, it's easy. And when I'm drawing the rectangle, I'm just taking the width I want and cutting it into 4 even pieces. I'm out of time. So I don't want to go over. I don't need to go